그럼 이제 첫 번째 강연을 시작하겠습니다. 처음 모실 분은 인공지능 연구에서 가장 두각을 드러내고 있는 학교 중 하나인 미국 스탠퍼드 대학교의 인간중심 인공지능 연구소 공동 창립자이시자 현재 부소장을 맡고 계신 컴퓨터공학과 공학 교수 제임스 랜데이 교수님이십니다. 랜데이 교수님은 학계 산업계를 망라한 거목이신데요. 코넬 공대, 워싱턴대, UC 버클리대 교수로 재직하셨으며 인텔 랩스 시애틀을 이끄신 바가 있고 넷레이커를 공동 창업하시기도 했습니다. 인공지능의 개발에 있어서 성능 측면에서의 발전 이외에도 인류에게 보편적이며 포괄적으로 사회의 이로운 발전 방향에 대한 연구를 계속해 오고 계십니다. 그럼 여러분, 스탠퍼드의 제임스 랜데이 교수님을 큰 박수로 모시겠습니다.
Thank you for that kind introduction, and thank you for having me here back in Seoul. So I'm going to speak today about how we can design AI to be more beneficial for humankind. And I've been working on this new way of thinking about how we should design AI over the last year. And what I'm going to want you to take away from this is that we need to design AI at the user-centered level, at the community level, and at the society-centered level if we wish to have positive impacts. So as we saw in the introduction, AI is taking the world by storm. Whether it's in scientific discovery with things like AlphaFold and some of the medical breakthroughs that we'll hear about later, or with natural language processing that simply works today and we're able to communicate with our colleagues all over the world and translate things quite well, to even fashion design, where fashion houses are using AI to predict which fashions are going to be hot in the next season and to also optimize their supply chain to make sure they're not wasting things. But the way that we've seen AI really taking the world by storm over this last year is with generative AI. So things like ChatGPT that many of you are using and trying to see how you can use it in your work, to generative images with things like Midjourney and DALL-E, where we can give it a short statement and get some image like this, to Copilot and other types of assistants that help us accomplish more complex tasks. But my claim is, although these technologies brought AI to the public's notice over the last year, this deep learning revolution has really been going on for almost 10 years, really starting in the early 2010s with the breakthroughs that were made in deep learning. And we started to actually see these changes in our products in the late 2010s. For example, speech recognition that started to work well on your phone, to how social media platforms adapted. And I would say in everyday life, AI has been there for a while. And this AI that we're seeing now is being produced with what we call foundation models or large language models. And the idea here is that we can take lots of data from the internet, think of almost all the data that's out there publicly, and then use a model that's trained on that data to then be able to solve many different tasks. And now we're seeing these foundation models that are trained on many different modalities, so not just text, it could be images, video, and audio as well. So in the old days of AI, i.e. a few years ago, you would train a different model for every task you wanted to support. And that was quite hard and expensive and brittle. With foundation models, the idea is that there's a few large players who spend hundreds of millions of dollars and maybe billions of dollars soon to build these large models, but those become a foundation that developers then build their applications on top of it. That's why we call these foundation models. And those models will work across many different tasks. Different companies might need to specialize those models, fine-tune them to do better with their own data, but this is the basic model that we're seeing today. Now, although this has been happening, again, my claim is that these AIs have been in your daily life already. So, for example, deciding what's in your social media feed or manipulating in some ways, which we've seen has made some people feel bad, especially Instagram and young women, or manipulating social networks for people to be deceived about what's true or not, affecting democracy in America as well as other countries in the world. We've seen also in the United States AI being used by judges to determine sentencing in criminal cases. And we found that some of these systems are biased, for example, against black people. You'll see here in the Compass system that was written a lot about. Given many of these both positives and negatives about AI technology, we founded the Stanford Institute for Human-Centered AI almost 5 years ago in anticipation of both these benefits of AI as well as some of these problems, and we wanted to get ahead of that. And our work there has really been founded on 3 key principles. So one, because of the impact and potency of this technology, we felt that we had to study things like ethics and bias and consider human impact on society from the start of AI projects and along their development and afterwards, but not simply afterwards to see if something is good or not. A second issue we've looked at is, although the deep learning revolution has really led to really useful new AI technologies, those of us who have been studying AI for years do not believe this is the end in terms of what intelligence machines will be like, that there's a lot more to learn. There's a lot more to learn from the human brain, which is at this point the most complex device known to man, and we don't even know how it fully works still. And so we believe studying neuroscience, cognitive and behavioral sciences, social sciences are another way for us to inspire new algorithms that will be useful as we move intelligent machines forward. And then finally, although there will be upheaval in the economy due to AI, and we believe governments and other public policy folks should be aware of this and be planning for it, we also believe that AI can be designed, if taught appropriately, to augment people rather than replace them. So help people be better at the skills that humans are already good at. So we want to have a design methodology that encourages that instead of a simple idea of replacing humans. Now, some of these issues in AI have led to a proliferation of what I would term AI for good institutes and initiatives. And they go kind of a couple of different ways that I've observed. In one case, they're often made up of social scientists who notice AI technologies after the fact, after they're already out in the field, and call the alarm on technologies that have harmful consequences. And although this is useful, what I'd really like to get at is how can we not build those things in the first place and find those problems earlier on in our design process so that we don't have to, after the fact, try to stop them. The other way that many of these initiatives go is technologists think about a human impact area like health or education and decide, oh, they're going to use AI for good, but they tend to go it alone. So as has been seen in many of our short-term crises, whether it's COVID, where people built a lot of AI-based tools and spent a lot of resources, many of these initiatives fail to produce anything useful for people. It's not just in the short term, it's also in the long term. So in 2015, one of the key Turing Award winners who developed deep learning, Jeff Hinton, which is the equivalent of winning the Nobel Prize in computer science, said, we should stop training radiologists now because in 5 years, AI will be better than radiologists. Luckily, we didn't listen to Jeff here because this has not become true. It's not true in radiology, it's not true in skin cancer detection, and it's not true in many other fields. Now, it's not to say that eventually those systems won't get better, because many of the problems that you see earlier on are when technologists tend to have very clean training sets that they test these algorithms on and they publish their papers showing, hey, it works. But then when you try to apply that in real messy clinical situations, it doesn't. Many of those problems will be solved over time. But I think the bigger issue here is that they're often solving the wrong problem. They're trying to replace the radiologist. Instead, we should be looking at how do we augment the radiologist? How do we give a radiologist the tool to do better at the job that they're doing and take advantage of the skills that they have in years of training in this problem, as well as their skills as a human and their judgment, and compare that with the AI to do better. So as my colleague at Stanford, who's in radiology and AI, Kurt Langlotz, wrote in one of his papers that was then publicized more in the New York Times, he said, will AI replace radiologists is the wrong question. Instead, the right answer is radiologists who use AI will replace radiologists who don't. You can take that same template of a sentence and replace radiologists with many other occupations, and I think it will become true. So it's really important for people to think about how might I use this technology and what I do to be better at what I do, instead of thinking, how do we just replace people? So we have a problem is that although I claim we want to create technologies that's going to be more positively impactful for people, we don't really know how to do this. And so that's what I've been trying to develop, is a vision for how we can create more human-centered AI. And as I said at the beginning, I believe if we analyze problems at the user level, the community level, and the society level simultaneously, we can come to solutions that will work better than those that have been produced today. So if we do that, we have a better chance that this type of technology will make a positive social impact. So let me try to unpack that a little further and talk about what do I mean about analyzing at these three levels. So what is human-centered AI? It's about who do we study to first find the problems we're trying to solve, then to develop the solutions, and then who do we study with to evaluate whether we've actually solved it. So where do we start? We start with user-centered process. So this means understanding who the users of our system we're developing will be and testing iteratively with them as we go along. This is not a new field. In fact, this is a field I've worked in for over 30 years, but it's taken almost 20 of those 30 years for this to become a very accepted industry practice. Instead of designing for engineers who say, hey, I can use it, it should work, instead we design for the people who are actually going to use our products. Obviously here in Korea, you've learned that quite well with a lot of great work in design. But we need to go beyond just having a good process. We need to make sure that we understand the cognitive way that people think. We need to understand the current workflows that they use. And then we need to be creative in coming up with new solutions that will help augment people rather than replace them. But I would claim this is not enough. Because if we look at even that case where I explained how the judge would use the compass system to sentence people, we could create a great user interface with very nice visualizations for that judge, but that wouldn't solve some of the underlying systemic issues that were inherent in the compass system. Okay? So we need to understand what is going on beyond just the judge. For example, we might want to understand at the community level other players who are in that question. So for example, the accused and their lawyers and their families, or if there's a victim in the crime, similarly, the victim, their families, their lawyers, the communities they come from, and any systemic issues that may affect this situation, for example, in the United States, racism. But again, that might not be enough. We need to understand things at a broader society level. For example, what happens if the AI system we're building becomes very successful and ubiquitous? Are there harms that it might cause? And so in this compass example, again, we might want to understand how does this interplay with questions of, for example, who's in prison in the United States, where a large percentage of black males have been in the prison system, or people who are caught using illegal drugs. These are questions that have large systematic and societal costs, and we need to be able to forecast them and forecast how our systems we build may interact with them. Now, that's not easy, but it's certainly not easy for technologists and computer scientists who've not been trained in any of this type of analysis. So this is why, to avoid some of these problems, we need teams from the start who are interdisciplinary. So this means we need AI experts and designers, but we also need folks from the social sciences and humanities who may be important to the problems that we're posing as well. And then we may also need domain experts, whether it's medicine or law or environment, depending on the domain that we're working in. And we need these teams to be true partners from the beginning so that they're trusted by their teammates rather than at the end ask people to check, hey, is this safe? We've seen that in industry, that method fails. So I want to run you through one example briefly of what this analysis might look like. So let's take the example of autonomous cars. This is a Tesla Model S, has an optional self-driving mode, full self-driving, or what autopilot they called it originally. My claim is this is not a new technology. You may have only read about autonomous cars in the last 10 years or so, but this is a technology that's been developed since at least the 1970s. In fact, when I was a graduate student at Carnegie Mellon in Pittsburgh in the early 90s, there was a truck that drove through the park next to the campus. It drove quite slowly, maybe 10 miles per hour, and it had a lot of Sun Microsystems workstations in the back to power it, but that was one of the early successful attempts at autonomous driving. This work's been going on for a long time. But I would claim that the work has been short-sighted in some ways in that it's been always focused on the driver level. How do I replace the driver? So maybe in the Tesla, what do you see on that screen in the middle? Or more importantly, the screen that's behind the steering wheel. What might I see when I'm in autonomous mode? And how might I get the user's attention, the driver's attention, let's say, if my inferences start to go poor because I haven't mapped this road before, or the weather is different than what I expected, or the other cars aren't behaving like I would like to see. My claim is these other levels, for example, the community server level, are also important to both solving but even posing this problem correctly. So what do drivers and other vehicles do? I don't know what you've seen in Seoul, but in Palo Alto, we have autonomous cars or test cars everywhere. You see them all the time. Well, what did they figure out? They learned people driving regular cars drive differently when they see an autonomous car near them. This could have been easily anticipated long before deployment if they had thought about these things at this different level and involved other people in that design. Similarly, pedestrians and bicyclists, these are also problems that are ignored. And many of the early problems, including deaths, have occurred because it was an afterthought. For example, someone who had a bike, but they were walking across the road with their bike. They were neither a pedestrian or a bicyclist. The AI system couldn't figure it out, killed the person. Okay, these are things that could have been anticipated much earlier if we had thought at this different level of analysis. But I think even more important is this question at the society level. Maybe autonomous cars aren't all they're cracked up to be, as their supporters would say. You know, it's possible that autonomous cars actually might lead to people driving more miles and potentially having more fatalities. So you might say, why is that? Well, for example, I live on the Stanford campus. It's about 40 miles south of San Francisco. If I was going up to the city to watch a show with my wife, I'm not going to pay $50 to park my car. I'm going to send it back somewhere south of San Francisco, maybe even all the way to my house because it's safe there. So that car is going to go twice the number of miles. Or maybe I don't want to pay millions of dollars to live on the Stanford campus, so I'll move 2 hours to the east, to the Central Valley, and I'll sleep in my car on the way in every morning. Or like many faculty, I'll just do PowerPoint slides. But whatever, I'm going to drive many more miles. It's this kind of behavior change that one could start to understand at the societal level that may lead to different behavior and therefore different outcomes for this. Now, this is not just newspaper headlines that you can find out about it. Researchers in transportation, for example, at the University of Texas at Austin, found that at least in what they call the Texas Triangle mega region, which I always want to think there's 3 cities, but there's 4. It's Houston and Austin and San Antonio and Dallas. In that region, the behavior changes that autonomous cars will bring is expected to lead to major traffic snarls and jams. So these are kind of costs that one could anticipate if we did this kind of analysis early on. So you can read the paper there if you want to know more. But my claim is if we did this analysis earlier, we might instead ask, is this where we want to expend our national or local resources? Is there something else that might be better? Here in Seoul, you're lucky to have really great public transportation in terms of subway and buses and things like this. In the United States, we often travel somewhere else and we come back and say, well, why can't we have this? Well, we can't have it because we don't actually ever ask the question and try to analyze it. Right now, it's a question of power. Who has the power to make these decisions? And this same question of power that I just gave as an example here with cars is a thing that we're going to see with these foundation models. These are models that only a few big, huge companies have the money to build, and sometimes even countries. So now the question becomes the power of who decides what's in those models, who decides how they're used. These are questions that society is going to need to deal with. So what I wanted you to take away from this talk is AI is changing the world. Much of it is going to be for good. We can use AI to help us be better at what we are already good at, so we can be better designers, take better care of our health, be better learners. But to do this well and to have positive social impact, we need to make sure that we design and analyze these problems at the user-centered level, the community-centered level, and society-centered level simultaneously and early on. And we need to do it with interdisciplinary teams. This is really a new area. It's just starting to develop. It's very exciting, but I think we're going to end up with very positive uses of AI if we think about it in this way. Thank you for your time.